All right, welcome to the law of large numbers. The law of large numbers states that when you run an experiment, so if I run an experiment and I get some data, that can tell me just what my experimental data is. I don't want to use my experiment to then predict what's going to happen over a lot of trials, or the law of large numbers, because the experimental probability will eventually turn into the theoretical probability, which says that theoretically if I flip a coin I should get heads half the time. Well, what could happen is I could flip a coin and I could get tails. Well, that's my one experiment. My one experiment tells me that I got tails. So if I were to think that that's the only outcome that could come up is tails on a coin, then I would say, oh, every time you flip a coin, it's going to be tails, tails, tails. No, we know that it's 1/2. Just because you had one experiment, even if you had tails, 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 like if you flipped it 3 times in a row, your experiment would say the chance of getting heads, what's the probability of getting heads? Would be 0. So you would say, well, you're never going to flip heads on a coin. But we know that's not true. That's why we can't base decisions off of experimental probability. We have to use the mathematical or the theoretical probability of what's going to happen. Now I'm going to skip over this Skittles example. I'm actually going to work on this one. This one is more of an understanding question to help you with this. So Jessica rolled the dice. It has 10 faces on it. So we're going to assume that they're numbered 1 through 10. It should say that here. She rolled a 30. She rolled it 30 times and got the number 9 4 times. So probability of rolling a 9 in her experiment was 4 out of 30. What is the experimental probability that a 9 will come up on the next roll? For her, she's been rolling 30 times. That's her total. The number 9 came up 4 times. So 4 out of the 30 rolls were her number 9 that came up. Now, that does not mean that that's always going to be the percent chance of rolling a 9. Just because she did that doesn't mean it's always true. Because if I do 4 divided by 30, I get 13.3%. Or if I math frac that, that's the fraction 2/15. So she ended up with 2/15 or 13.3 repeating percent. That does not mean it's always going to be that. What it does mean is that she's got 13% on her trials, but if it's numbered 1 through 10, then the probability of rolling a 9 is 1 out of 10. There's a 1 out of 10 chance that she should be rolling a 9. 1 out of every 10 times. So she should have gotten 3 out of 30. That would have been more along the mathematical theory. Now, if I roll this dice 500 times, which is going to be a lot of trials, that means if I rolled this thing 500 times, I just take it times the probability of that event. It's 1 out of 10. So it should be 50. She should be getting a 9 50 times out of 500 because it's 1/10. It's 1 out of 10. It's 10% chance. Each one of those numbers has a 10% chance. So the big idea for law of large numbers is you base your decision off of what is the theoretical probability. What does the theory tell us that that probability should be coming up? And then you just simply multiply by the number of times you're rolling or counting or flipping or picking a card, whatever it might be.